is a good order to fill out the table? Well, first, when output is 0, total variable cost is 0, so we can fill that 0 in. Well, next, total cost is the sum of the TVC and the TFC. So when we see that TVC is 0 and TZ is 720, it must be that TFC is 720 when quantity is 0. So TFC is always 720, so you can fill in that whole column. We can also now find AFC easily by dividing TFC by Q in each row. Fill in the whole AFC column now. Next, we can fill out the row Q equal to 1. Total cost is a sum, right? So the TC is 727. We can also divide this by quantity to find the averages. And the marginal cost is 7 since our costs increased by 7 when we increased output by 1. So delta Q, delta quantity in this table is 1, easy division and intuition. So next, we can fill out row Q equals to 2. TVC must be 20, right, from that Q equals to 2. Divide this to find the averages. Marginal cost is now 13. In row Q equals to 3, we can find a TC first by adding a VC and the AFC. So now we get a TC of 255. Then we can multiply the averages by quantity of 3 to get the totals. And here we can get MC of 25. In row Q equals to 4, we can find AVC by subtracting the AFC from the ATC. So we get AVC of 22. Then we can multiply to find the totals. Subtract current TVC from the previous TVC to get the marginal cost of 43. Now it's time to graph these cost curves. The greater the quantity of Big Macs produced, the higher the total costs. The total cost curve is upward sloping. So at first, total cost rises as at a decreasing rate due to gains from specialization. Eventually, diminishing marginal product causes the total cost curve to rise at an increasing rate. This point in the curve is called an inflection point. Costs are increasing at a decreasing rate, then it switches to costs are increasing at an increasing rate. Note that the entire curve is still sloped upward though. More production means more total costs. Now, I have a question for you. Why is the vertical intercept positive instead of at 0 for the total cost curve? And the answer is because of the existence of fixed cost. Even though the quantity is 0, you have fixed cost to pay. So from this total cost curve, the TFC is simply $100. The TVC curve starts from 0, which means when you produce nothing, the total variable cost is 0. And the distance between the TC and the TVC curves is simply the total fixed cost, $100 in this case, at any quantity produced. The marginal cost curve, the average variable cost curve, and the average total cost curves are U-shaped. The average fixed cost function is downward sloping, which is a spreading overhead, remember? So sometimes we don't even draw the AFC curve because of its uninteresting shape. Note that the marginal cost curve cut through the average variable cost AVC curve and the average total cost ATC curve at their lowest points. This reflects the mathematical relationship. The marginal cost curve reaches its lowest point before the lowest point in the AVC and the ATC curves. For this reason, a business executive concerned about rising costs would look to the MC curve as an early indicator. Once marginal cost starts to rise, but it is still below the AVC, it continues to pull down the average variable cost until, on this graph, sales reaches 60 Big Macs. After 60 Big Macs are sold, marginal cost is above the AVC, and the AVC begins to rise as well. However, when you look at the ATC continues to fall until 70 Big Macs are sold. Why does average total cost fall while MC and AVC are rising? The answer aligns with the average fixed cost, the AFC curve. Since the ATC is the sum of AFC and the AVC, and you can see that AFC declines as output rises, so ATC declines until 70 Big Macs are sold. After that point, increases in output cause all three of the U-shaped cost curves, the MC, the AVC, and the ATC, to rise. It makes sense that variable costs should initially decline as a result of increased specialization. However, at some point, the advantages of continued specialization are overtaken by diminishing marginal product. So the transition from falling cost to rising cost is of particular interest because as long as costs are declining, the firm will be able to lower its cost by increasing its output. Economists refer to the quantity of output that minimizes average total cost as the efficient scale. Margin and average relationship. How do we know if the average cost will increase or decrease when we produce more? Well, the simple answer will be that we need to compare the current average to the marginal cost of producing another unit. Well, we can think about the process we use to describe your GPA. A good grade brings your grade point average up, and a poor grade brings the average down. Similarly, the marginal change always leads the average. When the marginal cost is below the average, it brings the average down, and when the marginal cost is above the average, it brings the average up. Two examples for you to think about: class GPA and sports statistics. Let's start with the class GPA. On this slide, you see two photos of a male student, studying hard, and a female student snoozing while trying to study. Suppose the class average grade on the economics exam is 85%. Smarty McGenius joins the class and gets 100% on the exam. What do you think would happen to the class average? Definitely, the class average rises. But lazy no study son joins the class and she gets 34% on the exam. What do you think would happen to the class average? Definitely yes, the class average falls. Again, margin leads the average. Now, let's look at the sports statistics. Suppose James has a scoring average of 30 points per game. If he has a game in which he scores 45 points, what do you think would happen to his average? Yes, his average increases, right? If he has a game in which he scores only 12 points, what do you think would happen to his average? Again, yes, his average decreases. Once again, the average follows the margin. Now it comes to the most important question. Why are the short-run cost curves, including the ATC, the AVC, and the MC, U-shaped? The answer is diminishing marginal product. Explanation? Sure. Assume all labor is paid the same wage and each individual worker has the same quality. Eventually, each individual labor or worker brings in smaller and smaller contribution to the total production, which means each worker becomes less productive at the margin. Also lower productivity, right? But each of these workers cost the same. This implies that eventually the output costs will start to rise. Is there a mathematical relationship between input productivity and output costs? The answer is yes. Marginal cost is the wage rate divided by the marginal product of labor. So it means the lower the marginal product of labor from diminishing marginal product of labor that we learned earlier in the first part of this module, the higher the MC. Example, assuming two workers, Bob and Jack. Each worker gets paid wage rate of $100. If Bob, the first worker, has higher marginal product of labor and produces quantity of 20 units, the cost of those output units is $5 each. If Jack, the second worker, has lower marginal product of labor than Bob and produces quantity of 10 units, the cost of those output units is $10 each. It is not that Jack is dumb or unmotivated. He may have just been hired at a time of low marginal productivity. There may have not been a task left that he could specialize in. All right, so let's move on to the next part.